Here is the high-yield study summary for the remainder of Chapter 15 covering causes of denture fractures, denture base repair procedure. Here is a high-yield study summary covering Chapter 15, refitting and repair based on the provided images. 1. Refitting, Overview. Definition and scope. Refitting involves techniques aimed at prolonging denture life without manufacturing a new prosthesis. Key options include tissue conditioners, resilient liners, soft liners, relining and rebasing. 2. Tissue conditioners. Core concept and mechanism. Purpose: soft, resilient materials used to treat abused or irritated denture-bearing mucosa without requiring full removal of the denture. Mechanism: they flow under pressure to form a cushion that equalizes masticatory forces and eliminates pressure spots. Reversibility: effective only for reversible tissue changes, e.g., tissue abrasion, ulceration, swelling. They do not resolve irreversible changes, e.g., tissue hyperplasia or hypertrophy. Composition: powder, poly, ethyl metaacrylate. Liquid, mixture of aromatic ester and ethyl alcohol. Setting process: a physical gelation process, dissolution of powder in liquid, without polymerization. Indications and uses. Primary use: treatment of chronic denture-induced soreness. Adjunct uses: tissue conditioning during fabrication of new dentures, for conditions like bruxism, papillary hyperplasia, or avitaminosis. Temporary obturatus, e.g., post-maxillectomy for 7 to 10 days. Surgical splints or stents following vestibuloplasty. Stabilization of record bases. Functional impression material for atrophic ridges. Test material to determine potential benefit of a permanent resilient liner. Clinical key points and maintenance. Denture preparation. Occlusal disharmonies and improperly extended borders must be corrected prior to placement. Relieve 1 mm of tissue surface while maintaining 3 vertical stops. Replacement schedule. Needs replacement every 3 to 4 days until tissue recovery occurs. Prolonged use beyond its soft state causes trauma. Patient post-care. Avoid hard food for the first 8 hours. Clean using a soft brush under cold running water. Do not scrub with a hard brush or soak in denture cleansers. Commercial examples: Co-Comfort, GC Soft Liner, Viscogel. 3. Resilient liners, permanent soft liners, definition and duration. Elastomeric polymers used to absorb impact forces and prevent chronic soreness. Duration: intended for long-term use, lasting up to 5 years. Average satisfactory service, approximately 7 years. Heat process to the hard denture base. Categories: acrylics, plasticized acrylics, primarily temporary, tissue conditioners. Silicones, siloxane polymers, more durable and suitable for long-term soft lining, e.g., Monoplast B. Key indications and limitations. Indications: severe ridge atrophy, resorption, bruxism, undecayed areas, oral defect restoration, xerostomia, edentulous arch opposing natural teeth. Limitations and high yield rule: must maintain a minimum thickness of 1.5 to 2 mm to be effective. Cannot be used in thin sections. Difficult to trim, adjust, clean, and bond permanently to the acrylic base. 4. Relining versus rebasing. High yield distinctions. Feature: relining, rebasing. Definition: resurfacing the tissue side with new base material for accurate adaptation. Replacing the entire denture base while retaining the existing teeth. Indication: minimal to moderate ridge changes, post-immediate denture fitting, 3 to 6 months. Extensive tissue changes, porous, discolate base, or porcelain teeth requiring replacement. Indications and contraindications. Indications: adaptation loss due to residual ridge resorption. Unstable or loose dentures with acceptable aesthetics and jaw relations. Relining 3 to 6 months post-construction of immediate dentures. Geriatric or medically compromised patients unable to tolerate new denture fabrication stress. Contraindications: excessive ridge resorption, requires new denture creation. Presence of abused, hyperplastic soft tissue, must recover first. Unresolved TMJ problems. Poor aesthetics, unsatisfactory jaw relations, severe speech problems, or severe osseous undercuts. 5. Relining procedure. Key steps. Preparatory phase. Tissue preparation. Mucosa must be free of irritation. Leave denture out for 2 to 3 days prior, surgically excise persistent hypertrophic tissue. Denture preparation. Correct borders, relieve undercuts, eliminate occlusal disharmony via selective grinding, and establish posterior palatal seal. Impression techniques. Static methods: open mouth versus closed mouth, Open mouth technique, Boucher, 1973. Denture used as a special tray. Tissue stops maintain vertical dimension. Surface relieved by 1 mm. Borders molded with low fusing green stick compound, final impression taken with Zoe paste. Advantage, selective pressure impression without occlusal interference, verifiable CR record. Disadvantage, risk of increased vertical dimension or anterior displacement during placement. Closed mouth technique, patient closes in centric position while impression sets. Functional method, uses tissue conditioners to record functional impressions over time. Here is the high-yield continuation of Chapter 15 covering relining impression techniques, chairside relining, laboratory methods, flask, articulator, jig, and denture repair. 1. Impression techniques for relining. Closed mouth technique. Procedure. The patient's existing denture acts as a special tray. Tissue surface and borders are trimmed by 1 to 2 mm, except the posterior border of the maxillary denture. Borders are border molded with low fusing green stick compound, and the final impression is taken with Zoe impression paste while the patient closes in centric occlusion. Advantages. Lower risk of increasing vertical dimension of occlusion, VDO, because the patient holds occlusion in centric. Less clinical time required. Minimizes forward shift, displacement of the denture during impression making. Disadvantages. Existing occlusion errors can produce pressure spots and an inaccurate impression. Hydrostatic pressure in the palate can alter vertical dimension. High-yield modifications to relieve hydrostatic pressure, make a new centric relation, CR, record before taking impressions. Escape holes drilled in the palatal vault, 5 to 6 mm intervals along a grooved line. Perforate labial and buccal flanges. Use of impression wax instead of Zoe paste, though wax carries distortion risk. Functional impression technique. Uses tissue conditioners or soft liners inside the denture as a dynamic functional impression material. Patient performs functional movements, swallowing, speaking, smiling, for at least 15 minutes. Tissue conditioner is worn for 3 to 5 days, adjusted, and once tissues heal, a wash impression, Zoe or light body, is taken directly over the functional material to complete the reline impression. 2. Instant chairside relining. Material, autopolymerizing, self-curing, acrylic resins applied directly into the denture base inside the patient's mouth. High yield disadvantages and clinical hazards. Exothermic heat. High heat generation during polymerization can cause chemical mucosal burns. Free monomer toxicity. Unreacted free monomer causes tissue irritation and allergic reactions. Material properties, high porosity, bad odor, poor color stability, and weaker bond strength compared to laboratory heat-cured resin. Not recommended except for replacing very small parts of the denture base. 3. Laboratory processing methods. The fundamental difference between lab processing for relining versus rebasing, relining, only old impression material, thin acrylic layer is removed and replaced with new resin. Rebasing. The entire denture base is eliminated, except the teeth and a 2 mm adjoining base border, and replaced completely with new heat-cure acrylic. A. Flask method. Reline impression is poured with dental stone to form a master cast, beaded and boxed. Cast with denture is embedded into a processing flask. Flask is warmed to soften impression material, compound before opening. Separating medium applied, heat polymerized resin packed, clamped, and processed. B. Articulator method. Master cast poured without separating it from the relined impression. A plaster platform layer, index, key, is built on the lower member of the articulator. Denture teeth penetrate the soft plaster by 2 mm with the occlusal plane parallel to the floor to create a precise index. Cast is mounted to the upper member. After plaster sets, articulator is opened, impression material removed, denture base trimmed, for reline or rebase, waxed, flasked, and heat processed. C. Jig method, Hooper's duplicator. Jig definition. A mechanical device used to maintain exact spatial and positional relationships between denture teeth and the cast during rebase, reline assembly. Procedure. Occlusal surfaces are seated into a plaster index on the lower member of the relining jig. Upper member is secured to the cast. Old base, impression is removed, base plate wax adapted, processed, and checked against the original plaster index to verify occlusion. 4. Denture repair, core principles. Etiology. Denture fractures commonly occur due to extraoral impact, dropping the denture. Intraoral flexural fatigue, underlying occlusal disharmony, heavy occlusion, or uncorrected midline stress. Critical clinical rule: always determine and correct the underlying cause of intraoral breakage before repair, or the denture will repeatedly break. Here is the high-yield study summary for the remainder of Chapter 15 covering causes of denture fractures, denture base repair procedure, and refixing broken teeth. 1. Causes of denture fractures and cracks. A. Denture factors. 2. Poor fit. Alveolar resorption leads to uneven mucosal support, flexing of the denture, and eventual failure. Warpage, dimensional instability or volumetric changes in acrylic resin during previous repairs. Relief errors, inadequate relief, failure to relieve bony prominences, e.g., tori, thin mucosa, creates fulcrum points, causing the denture to flex and fracture along the midline. Excessive relief, excessive reduction thins the base material, weakening its structural integrity. Inaccurate impression, cast. Inaccurate master casts lead to uneven support during masticatory load, inducing localized stress concentration and cracking. Inclusions, porosities, plaster dust, nylon filaments, or metal mesh embedded during processing act as stress raisers and accelerate crack propagation. 3. Incorrect tooth position. Anterior, outside axis setting. Setting upper teeth outside the crest of the residual ridge is the most common cause of midline maxillary fractures. Masticatory forces applied outside the ridge axis turn the ridge into a fulcrum, transmitting large bending forces to the midline. Management solutions. Extend the denture base wide enough to ensure supportive force on the contralateral side. Arrange teeth in balanced occlusion. Cast. Use a metal denture base. B. Fracture, debonding of teeth. Cuspal interference. Concentrated heavy pressure on a single tooth during occlusion can split or debond it. Excessive overbite, inadequate overjet. Traumatic contact on anterior teeth causes chipping or debonding. Excessive, incorrect tooth grinding. Excessive grinding of the ridge lap area reduces the surface area available for chemical, mechanical bonding to the acrylic base. C. Patient factors. Accidental impact. Accidental dropping of the denture is the most common overall cause of impact fractures. Anatomical factors. Deep labial notches created to accommodate a high labial frenum concentrate midline stress, leading to midline palatal fractures. High occlusal load. Heavy masticatory forces, e.g., bruxism, muscular patients, single complete dentures opposing natural teeth. 4. Denture base repair procedure, step-by-step, reassembly and stabilization, align fractured segments precisely. Lute along the fracture line with sticky wax and reinforce extraorally with wooden splints, sticks across the occlusal surfaces. Pouring the repair cast, pour dental stone into the tissue side of the reassembled denture to construct a master repair cast. Joint preparation. Once set, remove the denture pieces, bevel the fracture margins outwards to expand the bonding surface area, and cut perpendicular grooves, dovetails across the fracture line to enhance mechanical retention. Reinforcement, optional, metal wires can be embedded across the joint for added structural strength. Resin application and curing, paint the repair cast with separating medium. Reposition denture pieces on the cast, mix autopolymerizing, self-curing, acrylic resin, and pour, flow it into the repair groove. Secure with a rubber band and cure in a pressure container at 30 psi for 30 minutes to reduce porosity. Finishing and polishing. Remove from the cast, trim excess acrylic, smooth, and polish. 5. Procedure for refixing broken, debonded teeth. Grinding the recess. Grind out remaining tooth fragments and acrylic from the socket, denture base to create room for new resin. Tooth selection and indexing. Select a matching replacement tooth and trim its ridge lap surface. Anterior teeth. Position the replacement tooth, secure it with sticky wax at the incisal edge, and fabricate a plaster index over the incisal, labial surfaces of the target and adjacent teeth. Posterior teeth. Articulate the denture to maintain correct occlusal relationships and avoid vertical discrepancies. Resin application. Place the tooth inside the index, reposition against the denture, and apply autopolymerizing acrylic resin from the lingual or palatal aspect. Curing and polishing. Secure with rubber bands and cure in a pressure pot for 30 minutes. Remove index, trim, and polish. Chapter summary. Key takeaways. Relining is indicated for mild to moderate tissue changes, whereas rebasing is chosen when extensive base replacement is needed. The functional reline method is widely favored as it simultaneously conditions abused tissues while generating an accurate functional impression. Midline fractures are most frequently linked to improper tooth placement outside the ridge crest or unrelieved midline bony fulcrums.